I want to talk a little bit about sort of my experience with digital transformation, specifically energy, but more a little bit of context as to why companies, and I include myself in that in my former job with Pirelli. I think there's somebody in here from Pirelli, so I've got to be a little bit careful. But I also include myself in that, actually finding it a bit of a challenge and a little bit difficult. And I remember when in Pirelli, we started off with the digital, and I've seen this with other companies, that whether it's energy or efficiency or quality or whatever it is, every company starts with some incredible plan, and usually they find themselves sitting together 9 months later on with a reality that's looking a little bit like this, and scratching their heads as to why, because they've bought lots of nice technology, yet there doesn't seem to be any value for it. That applies to pretty much everything, including energy, and it doesn't actually just apply to us. I was very happy to see in season 3 of Drive to Survive on Netflix. Season 4 is absolutely rubbish. I've only watched 2 episodes. But season 3, there was a great quote from Gene Haas, who said, we have all this data and it still runs like dog shit, excuse me. And I really like this quote, and I've kept it because it was it gave a good feeling for thinking, okay, we're not alone, because F1 teams also seem to have the same kind of issue. They're struggling also to get value out of their data. See Mercedes today. But there is a certain issue digitally and a certain seriousness behind this. And one of the most serious images I've ever seen of this, which was depressing, was just before COVID in the Hanover Messe, so the biggest technical fair in Europe. Yeah, the main headline in a German newspaper, the Bild Zeitung, it's a bit like the Sun newspaper in Germany, just as bad. And was passiert da, tolles mit diesem Teller. So what amazing is happening with this plate? I was looking at this and thinking, God, this is Germany, who about 12 years ago started the Industry 4.0 support program to transform Germany's industry and the industry in Europe. And then, 10 years later, they're looking at a plate on the end of a robot and it makes the headlines. And this is a little bit reflective of the issues, I think, digitally we have with companies when we start approaching things where we could actually use the technology to get some kind of real value. And a picture like this I find it pretty sad, to be honest, and a metaphor for what's really going wrong. To try and give a bit of context as to why we get the approach wrong, and try to choose something that's sort of a little bit technical, maybe, but something we all know about. At least we've got slides about it. Whether we know how it works is another question. But facial recognition. If you take the process of recognizing a face, it's very similar to any problem you would have inside your company for defect reduction, efficiency improvement, energy improvement. You define your problem, you identify your problem, which in the case of facial recognition meant getting lots of experts with good knowledge to identify what you need to measure on a face. When you know that, you collect and classify the data. There's a huge amount of work. In fact, the first 3 blocks here are probably 90% of the work of recognizing a face. And then finally, you know how to leverage technology to get the value, and you create a model that recognizes a face and hopefully is not racist, as a lot of them have been proved to be. If you look at this process in terms of start to end, it starts with a why. So what do we need to do? And finally, it ends with how are we going to do it? And a company like, say, Facebook, God bless them, the tech approach would start with the why. And with facial recognition and all the other things they're doing, they start with the why. The problem for traditional non-tech companies, and from what I've experienced, is it nearly always starts with the how. So whenever you talk about whether it's energy, efficiency, or whatever it is, digital, somebody somewhere always says, the worst one is we need to predict something. We need to put some AI model in. We need a digital vision. And this is wrong. This is starting at the end. It's almost trying to create a problem that you can then solve using technology to tick the box that McKinsey can put you on a graph and say, I'm technological, isn't our going well? And it leads to, more often than not, companies taking very much an over-complex approach to what could be a lot of low-hanging fruit and simple value to be gained. And I think this particularly applies, from what I've seen in my experience, with energy. Probably the most exaggerated example may be energy. So energy, as we all know, is usually between 5 and 20% of the total cost of producing in a factory, let's say. It's gone up a bit more recently because there's a war, but I haven't updated the slides to include that. But this cost is enormous, and it's growing for various reasons. But if you're a company, particularly if you've not done anything really yet with energy, it's not all bad news. And in fact, I would say the closer you are to actually starting something, you're going to have a lot of benefits to be gained, and a lot of, like I said, low-hanging fruit. And speaking from personal experience, when you start just looking at energy, so not thinking about sticking a wind turbine on a hill or buying 50,000 solar panels or doing something like that, but just simply start looking at the energy, I've firsthand seen that you can usually save at least 10% of your current cost of energy just by knowing some of the details. And it's amazing how many companies, and again, I speak from personal experience here, don't often know the simple details. And it's strange that companies are like this, because if you're as old as I am, you'll know that when we first started solving problems and doing improvements and cost improvements in factories, we used to do Six Sigma. And Six Sigma is this define, measure, analyze, improve, and control. And the fundamental parts of that are the measuring and the analyzing. And I find with companies that they don't measure. So they know the energy cost, hopefully, because there's a bill. But beyond that, there's really no measurement. And if you can't measure, if you don't know where your energy is consumed, whatever you think, you're not going to be able to make improvements in the right places. You might cut the consumption you think of some machine by half and think it's saving you, but if that machine is only using 0.00001% of your entire consumption of energy, you spent a lot of time and resource, probably more than actually the saving that you've made. And it has to start, and it never really does in companies I've been to, also since Pirelli, with the simple fact that you have to measure. And what I mean by measure is actually starting right at the beginning with a cost deployment. This should be a standard for every company in terms of efficiency, in terms of labor, in terms of quality, in terms of energy, and it rarely is. So do you know in your company what your base load is for energy? So if your factory is running and nothing is being produced and everybody's sitting still, sometimes this can be 70% of your energy. Do you know this percentage? And on top of this, do you then know what the variable cost is on top of it? So when things are actually being produced, or somebody's toasting some sandwiches in the canteen or something like this, do you know the variability here? Because if you don't know these two basic numbers, saving with energy is going to be very, very difficult, because you're not going to know where you actually need to attack to have the biggest impact. Once you have this, what you should then do, but this diagram here, I simply just put into Google energy deployment, enter, and found this one. So it's completely lifted and copied for a schematic, because I can't show any real data. But what you should be able to do is break the energy down in your company and understand where the energy is going. So we haven't got towards any kind of solutions or anything complicated or a neural network or anything like this. But if you don't know the answers to these questions, you're not going to be able to address what is going to become a very, very serious problem if it's not already. And the good news is, if you don't know the answers to these questions, when you do, there's probably going to be an enormous saving to come from it. And when you do have this, you'll have some essential things that you'll need to do with this information. The first one will be, once you've got your deployment of energy, do you have some kind of KPI where you can actually quantify your energy use? So I've got an example here that I've seen in a company. It's a kilojoules per ton. It doesn't necessarily need to be that, but you need to have your energy quantified in some kind of way that then can be related directly towards what you actually make, therefore you sell. And that can be done in a different number of ways. It's not just about the number of kilowatt hours consumption or something like this. And along with the KPIs, are you able to see live what is going on the machines? Because if you've deployed and you know where it's going, you need also to be able to see on a fundamental level what is happening. And again, I've been to a lot of companies, and very, very few of them actually are able to tell you live on every single process what is being consumed and how it's been consuming in the past and what the current relationship is with the past. You must know this kind of information, this basic information, to be able to improve. And lastly, towards measuring, another really important one, which actually was my former boss in Pirelli told me, was you have to make everybody responsible. So if you want to, say you want to address quality, quality in a factory should be every single person's responsibility from the operator upwards. It's the same with energy. If you've just got some poor energy manager who's getting beaten around the face every morning because the bill is going up, this isn't going to improve everything. The way you improve things is you show people live the information, and you allow people to take actions where they can see the consequences of these actions. So if somebody on the shop floor has an idea and they implement it, they would like to be able to see the reduction in the energy live, the effect that they can have, because this motivates people. And along with the lack of measuring and live, too often I think in companies, energy is someone else's problem. So energy is something complicated with a big long-term project that just doesn't involve the majority of the workforce. And if you don't do this, then you're probably going to find it very, very difficult to actually attack what usually are very, very simple issues and savings to be made. Along with the measuring, so the base load, the variable, getting the trends, the deployment, there's also the analysis that comes into it as well. Now, I'm not particularly, well, the coding and things, etc., yes, but I'm not particularly technical with the energy. That I'll come to Mauro in a minute. But I did want to just give you 3 or 4 examples that I've seen live of what you can actually do when you have actually information available about energy and you've just started. And this, again, is probably teaching everybody to suck eggs, and it's very, very simple, but it's amazing the improvements that can actually be made when you start doing some kind of fundamental analysis. So if you take a factory, and the first thing you can do is, if you're measuring the consumption, again, it sounds banal and simple, but unless you have the information, you can't do this. You can immediately see what is consuming too much versus other identical processes, or also versus what it should be consuming. And one of the real cost impacting, my English has gone too long in Germany, cost impact is not English, but you know what I mean. The biggest impact on cost that I've seen actually is processes that degrade very, very slowly over time. So they add maybe 0.5% or 1% to their baseline energy consumption whilst they're running per week. Nobody human is going to see this. So nobody's going to notice this happening until the electricity bill or the gas bill or whatever arrives. If you have measurement and you have some simple information, so not complicated, but simple live, it's amazing how quickly and how much can be saved simply by noticing that a process just might need a drop of oil. And that can drop what is 130% consumption down back to the 100 level again. And this happens time and time again. It's amazing how many factories and processes are not aware of this simple basic fact: is everything running and consuming what it should be consuming? The other one is with maintenance. It's anomaly detection. You know, we've got algorithms coming out of our ears, or at least slides about algorithms coming out of our ears today. And another one is anomalies, so spikes in consumption. It's something, again, that if you've got the information, is extremely easy to detect. But it's rarely done. And when you have these spikes, more often than not, they'll give you a warning that something's about to break and you need to do something about it. Easily available information, massive saving behind it, and something that's just hardly ever leveraged and used. And the next example is insulation. So when you know your base load, when everything is sitting still, you can actually have a look, how much is this costing us? Yeah. And then what you'll probably find that there's 20% of that cost is leaking away through the roof of the factory, and perhaps you should put a little bit of insulation on it, or some insulation on the window frames, or maybe some of the piping that's running across the roof with the heating and things like that could also be optimized a little bit. So for a small cost, there could be an enormous saving. And that just comes simply from analyzing the information. Nothing clever, no gigafactory or anything like this, just simple, have a look at what we have and where the energy is actually going. And in fact, when you start doing this energy flow, usually a shock already comes from this, because you find, of course, that the energy that's flowing into your various processes is far less than the energy that's gone in. And usually that other big piece is leaking out through lack of insulation or something like this. And last but not least, there's something I've seen done in a couple of companies, is reuse of energy. So if you've got a process like extrusion, so you have a screw rotating, extruding plastic or something like this, that's going to generate a huge amount of heat. And usually they have cooling water flowing around the outside of them to cool the process down. It's just an example. Lots of other processes, similar thing. That cooling water will be hot when it's finished cooling. That could be used then, directed somewhere else to provide heating, for example. And you could also do exactly the same thing the opposite way around as well. When you've got water available, you could use it then to provide cooling, and backwards and forwards. You just use a heat exchanger to take the heat out. And again, this is something that's really simple, and something that only through a measurement and a deployment will you actually be able to understand and be able to do. But rather than go complicated into all of the complex, fancy technical things you can do with energy, I really think, and certainly from the things I've seen, that whilst it's a crisis today, and probably is going to get even more of a crisis, energy, I think a lot of companies have a huge opportunity to make massive savings with a lot of low-hanging fruit that comes very much from just simply measuring, analysing and getting everybody involved. The issue with all of this, though, the big issue and the biggest question that's already asked is very good, fantastic, lots of low-hanging fruit, but how do we get hold of the data? And in fact, I think the biggest limiter that most companies have for this is actually how to get hold of the information to be able to start attacking these various issues or potential savings that you have with energy. Getting hold of data is not my expertise, so I'm going to hand over to Mauro the Magnificent and get Mauro to talk a little bit more about how we get hold of the data. Thank you.